game theory. Today we will discuss about the game theory and the rule concept that are dominance. Right? What is the dominance rule plays in the game theory? The learning outcome of this will be identification of the dominant strategy. Yes, you will able to find out, you will able to recognize the optimum choice for the player that yields the best optimum regardless of the other actions. What the others are doing it doesn't feel up. You will take the outcome and find out the best optimum choice for the player. The second learning outcome for this is the elimination of dominated strategies. Like if you simplify the more games properly and remove the suboptimal strategy, and you will be more focused on the relevant strategic choice with the help of getting the dominant strategy route. The third learning outcome for this is the simplification of the game analysis, that it helps in reducing the analyzing the game and making it more easier to determine the strategic to be. Like with the help of a dominance theory, you will able to find out and the reason behind this complex game, and you will convert that complex game into an easy game. The fourth category under learning outcome for the dominance rule is the foundation for predicting the rational behavior. That it helps you anticipating the rational actions by undertaking the rational players avoid the dominant strategy. That means you are able to find out the rational behavior by help of dominance. Last, the learning outcome of this game theory and the dominance rule is the basis for the Nash equilibrium. As we have already discussed about the more about the Nash equilibrium, if you haven't seen a, kindly have a look on the previous slide. Use the dominance rule to identify the Nash equilibrium, as eliminating the dominant strategy often leads to an equilibrium solution. Yes. Now coming up to the more details, ma'am, exactly what this dominance is and how we can overcome with this dominance rule and apply and simplify the game and get strategies for the players, either for the player A or for the B. Like there are different categories and different rules in the dominance. The first one is the row dominance. Under the row dominance, we have the modified row dominance. The next one is the column dominance, and the column dominance we also have the modified column dominance. By one, we will discuss more details about what is actually row dominance and modified row dominance, and what about the column and the column modified dominance. Coming up to the first category of the row dominance, what is exactly a row dominance is? Please have a look on this matrix. This matrix is of 2 by 3. Like we have player A having a 2 strategy A1 and A2. Player B having a 3 strategy B1, B2 and B3. Their payoff matrix is given over here 4, 6, minus 5, 5, 6, minus 3. Now applying the rule of dominance, the row dominance, what we will do in the row dominance, we will find the row, the minimum from the other. Like you have to compare the rows, like each and every row and find out the which one is minimum over here. So start comparing, say example, I'm comparing 2 rows are there only. So we compare A1 with the A2, right? We have to compare exactly which one is more like lower one. So we will definitely find it 4 is lower than 5, 6 on 6, that's compare. Minus 5 is lower than minus 3. So which one is more lower, like row A1 or A2? So yes, exactly A1 is a lower as compared to A2. Each and every element should be lower, right? Each and every element of the row will be lower or equal to the other row, right? From this case, what we analyze, the A1 is more lower as compared to A2, right? So what we do, we delete the row A1. Example over here, please have a look on this slide again. So what we have done, we deleted the row A1. Now the new matrix, the player, the reason behind is this, we deleted the strategy of the player A, the first strategy. Now the player A should focus on the second strategy, because the second strategy will give you that player A the good and the best optimum answer for their solution. Right. Coming up to the next step that we have discussed about the first topic, that is a row dominance. But if I'm talking about column dominance, in the column dominance, what we have to do, we have to find out the maximum element of each column. In the row, we find out minimum. Right, we have already discussed the row min, column max. Right. Now we have to find out the maximum in the column. Which one is maximum in this column? Like compare it the column from one to another. Like I'm comparing B1, B2, 2 strategies are there. Now compare it like 2. I'm comparing B2 right from B1. So having a look on the B2, what we are seeing up 2 is less than 4, minus 1 is definitely lower than 0, and minus 3 and minus 3 is counted. What we get it, but we don't have to find out the lower, we have to find out the maximum. So here the maximum one will be B1 or B2? Yes, definitely it is B1. Then we delete this B1. So what does it indicate? This indicates that for the column, we have to find out the maximum, and for the row, we have to find out the minimum. And for this, like column dominance, what we deleted the maximum column elements of each column of each cell, right? Then the player B will be more focusing on the B2 strategy, and we deleted the B1 strategy. This is a very simple example of row minimum, row dominance, and the column dominance. Now coming up to the third category that we have discussed about the modified row dominance. Now what happens sometimes we are not able to find out exactly one row that dominates the other row. Right? We are not able to find out the minimum element of each row. Then what we do, we use the concept of modified. That means we take the average of two and then compare with the third row and then delete that the minimum row. Like we have to take we have to play a game. Which two average of which two rows we have to take on? Like for example, over here we have taken an average of A1 and A2. Then A1 and A2, you have to do the average. 2 plus 5, that will be 7. 7 upon 2, that is 3.5. And 4 plus 0, that will be 4. 4 divided by 2, that is 2. Then the average will be 3.5 and 2. Now compare 3.5, that is average of A1 and A2 with the A3. 3.5 is greater than 0 and 2 is greater than 8, right? 2 is less than 8. So we are not able to find the situation. Then what we have to do again, we have to play the game like which two average we have to do. Now what we have to do, we have done the average of A2 and A3. Find it over here, we find the average of A2 and A3. Right, we do the average of A2 and A3, 5 plus 0, then the average will be 2.5. 0 plus 8, then we done the average, that will become a 4. Now compare this average value of 2.5 and 4 with the A1. A1 will be 2.5 is greater than 2, that means A1, 2 is lower. Then comparing 4 with 4, then again 4 is lower. So what we have result find out that A1 row is the minimum with the average of A2 and A3. So we deleted the row A1 over here, applying the concept of modified row dominance. Hope it is clear. Fine. We will able to find out when we have different rows and we are not able to apply directly the row dominance, then we will apply the modified row dominance concept over here. Right. Now coming up to the fourth category, that's a modified column dominance. Yes, again you have to follow the same rule over here. You are not able to find out the maximum column as compared to the other column. So what we do modify. But first step, we always follow the concept of what's the concept we have to follow. First of all, we have to follow that we can get easily the maximum column as compared to others. Once we are not able to find out the maximum column as compared to others, then only we will apply this concept of modified column dominance rule. Right. Now again we are taking the average of the two columns. Like for example, I am taking the average of 1 and 2. If or I just take an average of, if you say very easy if I want to compare it. But remember in the column we have to select the maximum one. Right. Now we are taking what we have done, we have taken the average. What we have taken average of 2 and 3. Compare the average of column 2 and 3. 15 plus 1, that will be 16. 16 divided by 2, that will be 8. Right, then we have written over in the left side, we have written 8, right, minus 1 and 4, that will be 3, right, and 3 upon 2, that will be 1.5. Now compare the average of second and third column with the column number 1. What we will get? We will find out that column number 1 has the maximum value that's compared to the average of second and third. So what we do? We will delete the column number 1 to get it modified column dominance and find the optimum strategy for player B. Now for the player B, what will be the optimum strategy? That will be the second and the third one. Right? Now we can easily apply the concept of 2% zero sum game. Hope it is all clear, the four topics which we have just discussed. What are the four topics? Just having a look on the diagram once again. First one is row dominance. That's a modified row dominance. The second one is a column dominance. Under the column dominance, we have a modified column dominance. Right. Now coming by example of each and every one, we will discuss with an example so that it can be more clear what we actually given up and how we have to do it. Now take a pen and paper and start working with the numerical number 1. Solve the following game using the dominance concept. Though it is written a dominance concept, but sometimes it is not given in the question, like you have to follow a dominance concept. So, but what you have to do in that situation, when the payoff matrix is given to you and it is written over there, just solve the game. What you have to do, you have to first simply apply the concept of saddle point. If there is no saddle point, yes, you have to apply the concept of saddle point. If there is a saddle point, that's very, very nice. You want to use the concept of dominance. And if there is no saddle point, then you have to use the concept of dominance. But sometimes there is a maximum strategy. What we have to do, we convert the maximum strategy into the simple one, and then we will find the saddle point. That will be a more optimum point. So when we are given a payoff matrix, we should first of all apply the dominance concept so that we convert that so many strategies into a 2% zero sum game. And then with 2% zero sum game, we can apply the concept of saddle point when there is a pure strategy. When there is no pure strategy, mixed strategy, then we can apply the algebraic method, which we have discussed in the previous session. Right now, again from this concept, first apply the dominance concept. Player A is having a three strategy A1, A2, and A3, and player B is having again a three strategy B1, B2, and C3. Now applying the concept of dominance, the first one is the row dominance. Having a look on the row which is minimum as compared to other rows. If you are able to find out that, then it will be very good. But if you are not able to find out, then we have to apply the modified row dominance concept. Right. So first we check either simple row dominance concept is applicable over here. So I feel like yes, it is applicable over here. Having a look as we comparing A3, compare the row that is strategy by the player A, third one, comparing with the other one, we will find that A3 is the minimum row as compared to A1 and A2. Like 4 is less than 6 if I'm comparing to A2, 2 is less than 4, B2 strategy, and 4 is less than 6. What we do, we delete that A3 strategy, right? Now the next step is lower down your reduce matrix. Now the player 1, that is player for the player A, you have 2 strategies, and player B, you have 3 strategies. This is the step number 1, row dominance. You can use the step 2 now. That your next step is to delete the column maximum. That's a column dominance, right? Now you have to use the column dominance. Column dominance, what we have to do? We have to find out the maximum column value. Now over here, please have a look what the maximum value for the player B. For the player B, we have the three strategy B1, B2, and B3. And what we are having a look on this, that B3 is having the maximum cell element as compared to what we compare it with either to B2 or either to B1. Look on that, either it's B1 or B2, compare it. I do feel a B1 and B3 compare that, right? 8 is greater than 4, 6 is again balanced, and 4 is again balanced. So as comparing B1 with the B3, we will find that B3 is having a maximum cell element as compared to B1. That's the reason we have deleted the B3. Right now we have the remaining matrix. That remaining matrix will be A1. For A1 we have two strategy A1 and A2, and for B1 we have the two strategy B1 and B2. Now this is the remaining matrix. Now what we have to do now, either you have to find out the saddle point, or either you can apply directly an algebraic method. Again, the minus the two values, that is 4 and 5 minus 4 minus 5, that is 1, but we are not using the minus 1, we will use only 1. 6 minus 4, that is 2, again 2 will we have to write it on the optimum, on the crisscross point, like for example over here, have another look, 4 minus 5, that we have to 1, but we have to write it on the lower side. 6 minus 4, that is 2, we will write on the upper side. Same with the B1, 4 minus 6, that will be 2, we will write on the this side, and 4 minus 4, we write it on the diagonal side, that is 1. Now again the optimum strategy for player A will be 2 upon 3, 2 plus 1, that is 3, 2 upon 3. For A2 it will be 1 upon 3, as there is no, we have already deleted the column row number A3, that's why we have written a 0 over here. Right, now the optimum strategy for the player B will be 1 upon 3, 2 upon 3, and that will be the last one is 0. And the last we have to find the value of the game, as we already discussed in many in the previous session. We just multiply the value, that is 1 upon 3 multiplied by 4 plus 2 upon 3 multiplied by Fine. Either taking the row wise or column wise, it's up to you. The answer remains the same. Hope you getting this example of like what we have done. We have used the numerical question of 3 by 3 payoff matrix and try to solve the concept of dominance concept in the game theory under the topic quantitative techniques for management. Right. Coming up to the next numerical part over here is like this. Please have a look on the numerical part over 2 that is solve the game using the dominance concept. What we have used in this is like we again have a three payoff matrix 3 by 3. Now apply the concept of row dominance and column dominance and find the value of the game as well as the optimum strategy for player A and B as already discussed in the previous example. First, again, you have to apply the concept of row dominance. Find out the row which is the less minimum as compared to others. If you are able to find it good, otherwise use the concept of modified row dominance. But we have discussed in this solution that it is very easy. We are able to find out the row that is A2 is the lowest row as compared to other row. Like for example, minus 3 is lower than which one? A1 that is minus 4. But if I compare it, minus 3 is lower than the minus 4, and then we have to compare minus 3 is less than 2, 6, 4 is less than 3, no. So what we have done, actually we have to compare it with A2 and A3. Now compare it, minus 3 is less than 2, yes, minus 3 with minus 3, yes, 4 compared to 4. That means we compare A2 with A3 and we find out the lowest one is A2. That's why we deleted the row A2 for the player A. The second strategy is deleted. Right now, coming up to the step number 2, that's column dominance. That's a column deletion point. Now you have to find out the maximum column by comparing the B1, B2, and B3. Now please have a look which one is more maximum over here is like if I compare B1 with B2, what will we get? Yes, 6 is definitely greater than minus 4, but minus 3 is not greater than 2. So we won't able to compare B1 with the B2. What we have to do now, we will compare B1 with B3. Like minus 4 is greater than 3. No, we compare it in this way, 3 is greater than minus 4 and 4 is greater than 2. But we will find yes, 4 is greater than 2. That means we will delete the column number B3 as it is maximum with compared to B1. Right. Now we will definitely get the payoff matrix of player A that is A1 and A3 and player B that is B1 and B2. Now your payoff matrix will be of 2 by 2. Now solve the following matrix in the same way as we used to do. Like minus algebraic method we have to apply 6 minus 4 minus 6 that will be 10 but we have to write on the crisscross that's the reverse side. 2 minus minus 3 that will be 5. You have to ignore the minus sign 5 on the top and then minus 4 and 2 that will be our column wise that will be 6 on the left side on the right side and the 6 minus 3 that will be 9 on the reverse side. Now we have to find it either to make it a smaller part that's like for example 5 upon 10 that you can do up 1 upon 2, 10 upon 5 you can do it too. It's up to you, make a smaller part that will be more good and you can easily solve the game by a simple strategy. But remember when we are writing the optimum strategy for the player A, remember you have to use C, it is given A1 and A2 is not there. So that means you have to write 0 for the strategy for the player A for the player A second strategy. So what we have to do, we have to write it 5 upon 10, comma 0, comma 10 upon 5. That is the optimum strategy for player A. And if I have to write for the player B, so B1 that is 9 upon 15. For B2 is 6 upon 15 and for B3 it is 0. We have to write in this way and then we have to finally find out the value of the game in the value of the game as we have discussed. Right. Thank you so much for today's session. In the next session, we will go more details about the optimum strategies and the game theory in detail.